How to do some of the problems on the Chapter 11 test. So this problem is a problem for cybersecurity, and it's just an easy example of using statistics for a practical application in the real world. So let's look at this. There's the data, and here's the output, and since the p-value is below 0.05, it's actually 0.0074, that means that the leading digits do not fit the distribution, and therefore it appears those times are not typical. So that is a good chance the computer has been hacked, so corrective action is needed. On the second problem on this test, this is called a goodness of fit test. So we are testing to see if the number of police calls are about the same frequency on every day of the week. So the null hypothesis is that they occur with the same frequency on the different days of the week. The alternative is that at least one day has a different frequency. So to do this, we'll click on Open in StatCrunch and click on Stats, Goodness of Fit, chi-square test, observe column and frequency, and click all cells in equal proportion because we're testing to see if the calls happen with the same proportion or frequency on each day of the week. And we get a chi-square value of 32.7418 and a p-value that's less than 0.0001. Round that off to 3 decimal places, round this off to 4 decimal places, and the conclusion is that we will reject the null because there is sufficient evidence to reject the claim that they have the same frequency. There is a huge problem with this, however. As you know, October has 31 days, meaning that there's 3 days of the week at the end of the month that happen more times than all the other days of the week, and so therefore those days would have more calls. This problem is another goodness of fit test to see whether candy is distributed properly. So this is the actual amount of candy that was observed, and the amount that should have been observed would have been 14% of 100 red, which would be 14, 22% orange, which would be 22, 12% yellow, which would be 12 out of 100, 9% brown, which is 9, 26% blue, which is 26, and 17% green. So I'm going to do stats, goodness of fit, chi-square test, observed value, and number and package, and expected is listed in expected. Click compute. So in this case, the chi-square value is that, and the p-value is 0.679. Now next it asks us, what's the critical value? What's the critical value? Well, to find the critical value, we have to use a 0.025 significance level. So let's go to Stat Calculator's chi-square, and let's find the probability. Well, we have 6 sample values, which means we have 5 degrees of freedom. And we want the probability to be greater than or equal to, and the significance level is 0.025. So 0.025, and the critical value that is exactly equal to that is 12.832502. Round that off to 3 decimal places. State the conclusion. So our test statistic is much less than that, and also if you look at the p-value for our original test, it's higher than 0.025 because it's 0.679. So either way, we do not reject the null, and there is not sufficient evidence to warrant the rejection. This one is a chi-square test for independence to see if whether or not a candidate passed or failed is independent. So the null of an independence test is that they are independent. In other words, they have the same chance of passing the test. The test statistic can be calculated by clicking on the data, opening it in StatCrunch. Now this is actually a summary of the data, not a listing of every individual candidate. So click on Tables, Contingency with Summary, and choose both of those columns. Those have the total numbers of each of the passed and fails. The row label is in the dash column, which indicates the category of the person. And then therefore the chi-square test statistic value is that. And round it off to 3. And the p-value is 0.0706. And this means that since the p-value is higher than the significance level, there is not sufficient evidence. There's not sufficient evidence to, well actually, this last one is worded wrong. There's not sufficient evidence to reject the null. The null is that they're the same probability of passing. So we would actually need to word that there's not sufficient evidence to support the claim that the results are discriminatory, which is the alternative hypothesis. So it's not if the p-value is higher than the significance level, then you cannot reject the null. So we cannot reject that they have the same chance to pass the test. That means you cannot accept the claim that they do not have the same chance of passing the test. So there's not sufficient evidence to support the claim that the results are discriminatory, meaning that they do not have the same chance of passing the test. So that's a kind of a confusingly worded question. Now let's look at this soccer data. So open this data in StatCrunch, and this is also a chi-square test for independence. So some people think that when you kick a soccer ball into the goal that it goes so fast that the person can't react, so the reaction is random. So here is stats. We're going to do the same thing, tables, contingency with summary. We're going to select all the summary data, and then the row labels are in the dash column, and then compute. So here we go. So the hypotheses would be that goalkeeper jump kick is independent of the kick direction. The test statistic is this one. Chi-square value is 10.17. So put that in there. 176 if I round it off. The p-value is 0.0376. The results support the theory that the kicks are so fast and therefore they have no time to react, so the directions of the jumps are independent of the directions of the kicks. So this actually p-value is less than 0.05. So no, well the significance level is 0.01 and the p-value is not less than 0.01. So actually there is insufficient evidence to warrant rejection of the claim that the direction of the kick is independent of the direction of the goalkeeper jump. So the results support the theory that because the kicks are so fast, goalkeepers have no time to react. Now remember, this data is not based on an actual experiment, so this doesn't really mean that a soccer goalie cannot tell which direction the ball is being kicked. So here we go, chest measurements. Okay, so this is talking about one-way analysis of variance, which is called ANOVA. These indicates that a one-way analysis of variance should be used. They are categorized according to the one characteristic of size, and the claim is being tested that they have the same test illustration. Why is the method referred to as the analysis of variance? It is based on estimates of a common population variance. And finally, question 7 on test for chapter 11. We are actually going to do an analysis of variance test. So open the data in StatCrunch. Click on Stats, choose ANOVA, click One Way, select all 3 columns, and then click Compute. And the hypotheses are that they all have the same mean, and the alternative hypothesis is that at least one of the means is different. The test statistic value is right here, F stat 4.204. Round that off to 4.20 because it says 2 decimal places. The p-value is 0.0272, which will run up to 0.03. And since the significance level is 0.05 and 0.03 is less than 0.05, I will reject the null hypothesis, which means that the type of vehicle, at least one of them has a different mean, so the type of vehicle appears to be different, so it appears to affect the amount of greenhouse gas for these three types. And there you go, that's how you can do the Chapter 11 test. Thank you for watching. Best wishes to you and Merry Christmas.